All right, next up, we're looking at some review problems for our circles test. These are mainly about angles, not much about tangents here. And this first one is kind of a doozy. It's got a lot going on, and it's one of those where I'm going to start by figuring out what I do know before I look over here and worry about any of this. So angle 1 is 50 degrees. Well, that automatically means that angle 5 is, because they're vertical angles. Measure of, and this must mean arc FA, is 75 degrees. Okay. So let's see. If arc FA is 75, let me see if I can find a decent color to do this with. F to C is 180. If I go from F all the way around to C, that's 180. So this part right here from A to C has to be 180 minus 75. So the measure of arc AC, and it doesn't say it here, but I'm going to put it up here. Arc AC has to be 105. Now here's why that matters. One of the angles that we're looking for is an inscribed angle on arc AC. If you look at angle 4, one side of angle 4 goes through C, and the other side of angle 4 goes through A. So angle 4 is an inscribed angle. It has to be half of 105, and that is 52.5. So let me go ahead and, I might write that here. Okay, so now what else we got? How about, oh, this is fun. This is a good one. This is 50. Do we have any angles that are intercepting the 75? Yeah, we do. Angle APF. APF is a central angle, so it's going to be the same as the arc it intercepts. And APF and CPD are vertical angles. So now I have everything except, let me grab something here. You've probably noticed I like to do this with colored paper. This is a diameter that I'm putting the edge of the paper right along. So everything over here has to add up to 180. Okay, so angle 2 plus 75 plus 50 adds up to 180. So 75 plus 50, that gives me 125. 180 minus 125 is 55. So this is 55, which means this is 55. All right, let's see what else we've got now. Well, here's a triangle over here. All three angles of a triangle have to add up to 180. So 75 plus 52.5 is what I've got so far. If I subtract that from 180, I get 52.5 again, which I probably should have just guessed because, or known, because they both have a radius. I mean, this is the two sides of the triangle are both radii, so that has to be an isosceles triangle there. All right, so now I'm noticing that FCD, one side of that angle goes through F, one side of that angle goes through D. So this is an inscribed angle that intercepts arc FD. So 52.5 times 2 is 105. So arc FD is 105. Well, we already know part of FD, we know ED is 50. So if I subtract 50 from 105, I get 55 for this one over here. All right, now I also know, since CPD is a central angle, that it has to intercept, the arc that it intercepts rather, is the same size. So CPD is 75, so this is 75, which also goes with the whole 105 thing. All right, I'm almost there. I'm getting closer to having all my angles. How about angles 10 and 11? Angles 10 and 11 have to be the same. Here's what I want you to notice about them. Both of them have a vertex inside the circle. Remember, thinking of outside, inside, and on. If we want to do inside, we have to know the arc in front of it and the one behind it. Basically, like that. So if I want to know angle 10, I have to know the 105, which I do, and I have to know the 55, which I do. So 10 is going to be 1/2 of 105 plus 55. 105 plus 55 is 160. So 10 is 80, half of 160. And so is 11. Finally, angle 9. There are a couple of ways I could do angle 9. I think the easiest might be angle 9 is an inscribed angle that intercepts the arc from E to D. So this arc right here goes with angle 9. Half of this is 25. Or I could have used this triangle right here. All right, so now I think I've got everything I need. I just have to list it. Angle 1 is 50. We already knew that. 2 is 55. 3 is 52.5. 4 is 52.5. 5 is 50. 6 is over here, and I never found it. Okay. I'm going to have to come back to that because I want to keep listing for right now. 7 is 55. 8 is 75. 9 is 25. 10 is 80. 11 is 80. Arc AB goes with angle 6. So that's an arc I have not yet found. So let's go ahead and do that now. I know that AC is 105. I also know that this angle right here is 55, which means this arc is 55. These two would be the same. So that's a part of AC. So if this is 55, then this has to be 50. You could also notice that this is 50. Okay, so arc AB is 50, and that's a central angle. So angle 1 goes with arc AB. They would be the same. Angle 6 is half of arc AB because it's an inscribed angle, so this is 25. Okay, so now we have arc BC, arc CD, arc DE, and arc EF. Wow. Big, long problem. Sorry, it's hard to see over there. Okay, C is the center of the circle. Well, then these are all central angles, and central angles are the same as the arc that they intercept. Notice that these two are a linear pair. So if I subtract 180 minus 135, I get 45, and this is 45. So X is 45, Y is 135. Next, if P is the center of the circle, look at what I've got. I've got a right angle right here. I've got a right triangle. One side of this triangle is the diameter, so therefore it's a right triangle. So B is 90. 25 here, this 25 right here, intercepts the arc that we're calling A. So if the angle has to be half the arc, 25 is half of 50. And what else have we? Let's see, C. I think angle C intercepts this arc right over here. If you look at angle C, it goes like this and like this. So it intercepts that arc. So I think we're going to have to figure out that arc by figuring out everything else. Notice that because I have a diameter, always look for a diameter because it tells you everything on one side of that's 180. So if this is 50, then from here to here is 130. Okay, and here to here is 58. So I can add up 58 plus 130 plus 50, and then subtract that from 360 and I get 122. So that's the arc. C is the inscribed angle that intercepts that arc, so it's half as big, so that's 61 degrees. Okay, I'm going to keep going as far as I can. I could get cut off any minute because they are actually replacing projectors on this hall tonight. So they may come in and tell me, we need your projector. All right, so let's see what's going on here. We have a quadrilateral inscribed in a circle. Every single time we have a quadrilateral that fits in a circle like that, the angles across from each other diagonally, opposite angles, have to add up to 180. So this is telling me this is 90. So that means this is 90. Okay, now, if that's 90, that's an inscribed angle. And look at the arc it intercepts. That tells me that this is 180. Okay, so if this whole part from this point around to this point is 180, then M is 180 minus 36, which is 144. All right, now, at this point we know every part of the circle except this part up here. Okay, I know 120, I know 144, excuse me, I know 36 for here, and I know 144 for over here. So I'm going to add that up, and I said 120, I meant 122. 122 for this arc, 36 for the one right next to it, right here, 44 for the one next to that, 144. I'm losing it, folks. It's like 5 o'clock. Time to go home. So this is all 302. If I want to know this part, I subtract 360 minus 302, and I get 58. And there we go. Next one is actually much more straightforward. It's just one angle. Its vertex is on the circle, so the angle is half the arc. So 4x plus 10 equals 1/2 9x plus 10. I can multiply both sides by 2, and what happens is this side gets multiplied by 2. This side, the 1/2 just goes away. So this is 8x plus 20 equals 9x plus 10. When I collect my x's on one side, I get x over here equals 10. So if x equals 10, then when I go back and plug in, I get 4 times 10, which is 40, plus 10. So this is 50 degrees. Now it's kind of confusing to see this didn't actually tell me what they wanted. If they wanted the measure of angle in LM, then I'm done. If they wanted the measure of arc in LM, that's all the way around here, then I would have to say, well, if this is 50, this is 100, and subtract 360 minus 100, and arc MLM in LM would be 260. Kind of ambiguous there. All right, next, number 6. In the diagram, E is the center, and arc AB and arc FBG both measure 73 degrees. Now look, we have a central angle right there. Angle AEB is a central angle, so it measures the same as the arc. Same thing here. If FG is 73, this is 73. All right, now look at how you have a diameter. AG is a diameter. So everything on one side of it has to add up. It's a semicircle to 180. So I have 73 and 73. If I add 73 and 73, I get 146. Subtract 146 from 180, and I get 34. All right, let's look at my vertical angles here. These two are vertical angles. These are not, but these two are. Okay, which makes sense again because 73 plus 73 plus 34 going along this line as well. These have to add up to 180, so that makes sense. I can figure out what this angle is by saying, well, this side has to be 180, and I already know that this part is 73. So 180 minus 73 is 107. So this is 107. This is 73. I think I might have found everything I need to. And again, I don't like the way they're writing this because some of it's very ambiguous as to what they're asking. AEB, I'm assuming they mean the measure of angle AEB. Let's add my little m, and that's 73 degrees. EGF, I'm assuming EGF, the measure of this angle is what they need. Now, we haven't found that yet, but we know that what is that? That's E. EF and EG are both radii, so they have to be the same. So we have an isosceles triangle here, and in every isosceles triangle, base angles are congruent. So if I subtract 180 minus 73, that tells me 180 minus 73 is 107. I could divide 107 evenly up into these two angles. So that's 53.5 and 53.5. So angle EGF is 53.5. Now this is where it gets kind of weird. Not weird, but more ambiguous in terms of what they're asking for. I don't think, we don't have any lengths whatsoever here. Okay, technically this should mean the length of segment BF. Number one, there's no segment BF drawn. That's one clue that they probably don't mean that. Number two, number two, we don't have a single segment length in the entire thing, including, we don't even know the radius. So I'm thinking they meant to do this. So the measure of arc BF is 34 degrees, and the measure of arc HG is 107 degrees. All right, next. Sorry if you couldn't see that really well. Come and get back. Next up, we're getting kind of algebraic on this one. In circle F, arc BC is 2 plus 20x. I'm going to write that as 20x plus 2 just because I want to. Arc CD is 15x minus 1.